Alright, student, let us start today's topic, that is area, and it is one of the very interesting and very easy topics at JEE Mains level. In fact, it is much more important as per se your board examination because a 6 marks or a 4 mark question can be asked. But at the JEE Mains level, a very simple question will be asked, and that is the reason that we will not be getting into the depth of this chapter where this chapter in IIT JEE Advanced majorly focus on your curve sketching skills. So though we are not going to do curve sketching, in fact we would be relying heavily on the basic questions and the basic graphs that we have already done in the functions topic. Alright, so before starting with the area, if you are not sure about how the basic graphs work, just revise the function class so that this chapter will become easy for you. Let's start the topic. Okay, now let us quickly understand the concept of area with the help of definite integration that we people have already done. So this is definite, right? So when we talk about area, we talk about area of first of all bounded figures, right? We do not talk about area calculating of unbounded or which are not restricted somewhere. So bounded regions or bounded area, or you can say bounded region. So what do you mean by bounded? So that means it must be having a certain boundary, and under that boundary you would be required to find the area. And how definite comes into help, let me just show you with the help of an example. So let's assume that this is fx, right, and this is your x-axis, right? For assumption we are taking it. So now let's quickly understand each and every component of your definite integration, right? So this is integrand and this is dx, right? So now if you want to bound this area, how you will bound this area? Let's say I say that you start integrating this from this, right? This is the first, and you put the end at here. So this is the starting boundary, you can say starting of the field ground or the playground, and this is the end point of the playground. This is where the playground ends, right? And these two are the other boundaries. Upper boundary, you can say upper boundary, right? I'll say this is the upper boundary just to make sure that you understand the concept, and this is nothing but lower boundary, right? Can I say so? So now can you see that this figure is completely bounded, because you cannot, if I say that you are being placed here, can you escape from here? You will try to move in each and every corner, but you will not be able to escape. So I say that this is a bounded region, and it is bounded by how many curves? Yes, it is bounded by four curves in a way, right? Four curves are there which are bounding it. What are those curves? This is the first, and which is actually your fx. Now keep understanding what is there in terms of definite, right? This, let's say the second boundary is your lower boundary, right? So what it signifies in the definite is this dx. So dx actually signifies the lower boundary, which is always the x-axis. This is x-axis. So this is the second boundary. Now let me talk about the third boundary. So the third boundary here, let's say, is the starting of the playground. This is nothing but a vertical line. Vertical line is always written like x equal to a, and this again is a vertical line which can be written as x equal to b. Can you see that this is limits is nothing, x equal to a and x equal to b. So this is your third boundary, and this is your fourth boundary. So that is why we say that definite actually gives you the answer of the area bounded by the figure, and actually this is nothing but area. But again, if we talk about definite, we did in definite that this is not area, this is algebraic sum of areas. This is the difference. Algebraic sum of areas, right? What do you mean by algebraic sum of areas? Let's just understand that also before we go ahead. I hope the concept of the boundary is clear, that how this definite portion gives you the area of the bounded region. Now let's say this is the graph of fx, right? This particular is y is equal to fx. Right. Now you say that you want to find the area when you travel from x equal to a to x equal to c, right? This is what is here happening. So a and c are actually the roots of this function, you can say. So that does not worry. So do not worry about whether I could have said that you can integrate it from here, where this is the x-axis. So you would have said, sir, I would draw something like this. It is exactly same. So do not worry whether a point lies on the axis, c point lies on the axis or not. It is immaterial. So now if you see the area, so there are two areas, above x-axis and below x-axis. And if I go by the definite property, let's say if you do something, the answer to this particular problem would be I minus 2, right? But we know that areas are never negative. They are always positive, right? They are never a negative quantity. So what you wanted out of this particular quantity to represent is that you wanted the area is 1 plus 2. This is the area that you people want to find, right? This is the exact area. So for this, what you people will do, so here actually the main question arises that here you need to know the figure. Figure is required, right? Or even if the figure is not required, you need to know where the curve is above x-axis or below x-axis, above or below. Because below, for below, what you will do, you will then do 1 plus modulus of second. So why I am saying modulus of second, you would do something of this sort, a to b fx dx plus b to c fx dx, but we know that b to c fx dx will return you a negative answer. That is why we'll put a modulus in front of it. Now this is the answer of the area bounded by the curve from a to c. This is how you have to apply the logic. I hope the logic is clear. Okay, so the curve can be any, but the area has to be always positive. So the region which is below x-axis, for example in this case here, right, you will have to take a modulus sign for this, otherwise you will get answer 0. So we did this in definite integration, where I also asked you to learn this, that the if I asked you the integral of 0 to pi 2 pi sine x, I told you to remember this as this is nothing but 0. But if I ask the what is the area, you will not say that area is 0. Area cannot be 0, right? This is the area 1, this is the area 2. So I told you to remember this. This is 2, this is 2. But if I ask the area of sine x, right, from x equal to 0 to 2 pi, then the answer would be not 0. You will say, sir, answer is 4, right? So I hope the concept is clear. So now let us talk about the methods of finding the area. So we have methods of finding area, right? Methods of finding area. So how do you can find area is basically there are two methods, right? So one method is what we generally follow is with respect to x-axis. You find the area with respect to x-axis, and the other thing that you can people do is find with respect to y-axis, right? And we'll follow that method where the calculation is the easiest. So for example, how you will be able to distinguish that you have to integrate with respect to x-axis or you have to find area or integrate with respect to y-axis is, let's see. So first of all, how you will write something here is that you will say x equal to a fx dx. This is with respect to x-axis, so that is why the variable of integration will be dx. Whereas if you want to talk about with respect to y-axis, what you will do, a to b, first of all with respect to y-axis, so the variable of integration will be y, and then you will also put the function in terms of y, not the function in terms of x. So here it is the difference. You have to, if I have to highlight, here the function was in terms of x, here the function would be in terms of y. This is the major difference. And also these values, that is y, a and b, so this is y equal to a and this is y equal to b here, this is x equal to a and this is x equal to b. Okay, so now when do you apply these kind of logics, that how you will decide which particular method is to be followed. So let me show it with you an example. So this is, let's say, draw the axis x and y axis, and the graph is something like let's say like this. Okay, so in these kinds of graphs can be followed by both the methods. In fact, it is equally good to do this. So if I say that I have this starting point, that you are traveling from this to here, right? This is x equal to a and you travel till x equal to b, and if you are comfortable in drawing the vertical lines, right, vertically you cut the rectangles, right? So if vertical rectangles are possible, vertical rectangles where you know the start point and the end point very easily, vertical rectangles with easy start points and end point, with easy start and end, right? Then you should do something with respect to x-axis. So the area that I can say is nothing but a to b, right, fx dx in this case. Okay, so now but let's take another diagram to just to highlight that what is the difference when I talk about the other case. So for example, this is the case where this is something of a, you can say, a sort of parabolic shape, right? This now is x equal to a. This is the only stuff that is given to you, right? Now how you will solve this? So if you start drawing the horizontal the vertical lines, you know the start point. So the vertical line starts from, this is the start point, right? So you know the start point when you are doing with respect to x, but you do not know the end point where it ends, right? You do not know the end. But whereas if you start drawing the horizontal rectangles, right, then you know the start and end point both, right? You know that this will be something y1 here and this will be y2. So I will prefer rather saying y1 to y2 gy dy. So if you are drawing the small rectangle, so area is nothing but calculated by rectangle that you people must have done. So if you are drawing vertical rectangles, right? The horizontal rectangles, vertical rectangles are here. So if you are drawing it in a way, let me just show it to you. Yes. So if you are drawing the vertical rectangles, then it is with respect to x-axis. If you are drawing with respect to horizontal rectangles, if horizontal rectangles with easy start and end points are available to you, horizontal rectangles, then what you will take, you will integrate with respect to y-axis, right? I'll take examples so that this concept becomes much more familiar to you guys, right? Now let's take the concept when not a single graph is there, is more than one graph. So for example, one graph is like this and the other graph is like this. I'll say this is y is equal to fx, right? And this the other curve is y is equal to gx, and you need to find the area between these two. And let's say this is the x-axis, for example. So you can by intersection find their point of intersection. You can easily find their point of intersection. That is what I am assuming. So let's say this is x equal to a, right, and this is x equal to b, right? So now your target is to find the area, and if you see that it is very easy for you to draw vertical rectangles, right? Because for the vertical rectangles, you know both the start and the end point. This is the start point of the rectangles, and this is the end point of the rectangles. So what I will do is I'll integrate this with respect to, first of all, x-axis. And what you will do, see, this is your upper curve and this is your, what I can say, this is the lower curve. So the answer is nothing but upper minus lower, upper minus lower. So in this case, the answer would be, area would be nothing but equal to a to b. What is the upper curve? Fx minus gx. And do not worry, even if you are not able to figure out which is the upper curve or the lower curve, you even have to take a mod, because answer cannot be negative. So that is not the problem at all. Just take the mod sign. Okay, the same figure could have been possible like this also. One is this graph and the other is this graph. Now if you see that, again I would say that this is y equal to fx and then this is y equal to gx graph, right? Now if you see, can you start drawing vertical rectangles? Think of this, that you will start from here. If you draw vertical rectangles, this start point is not given to you. That is the problem. Whereas if I start drawing your horizontal rectangles, this becomes much more easy, because at the horizontal rectangles, you know the start and the end point. This is the start, this is the end, right? So I would now prefer integrating this with respect to y-axis rather than the, okay, and in this particular case, I'll take this as right curve and the curve which is to the left. So what I will do, let's say this, I say y is equal to a is the intersection point, and here y is equal to b is the intersection point. So what you will do from a to b, right? Now do not do this error of saying, sir, I'll do fx minus gx mod dy. So this is completely wrong. Why? Because see, you are integrating with respect to y, and here they are functions of x. So that means you are not integrating anything, right? You will just put y here. So this is wrong. What you people have to do is that you will say a to b. Now you will have to use f inverse function, right? F inverse minus g inverse dy, right? Because they will be in terms of y. Or in fact, you can say that I would rather write this function as x is equal to fy function, and I would say this function is x is equal to gy function now. So then the correct answer would be, what you will do, a to b right minus left, right minus left dy. So a to b right minus left would be, which is the right function, gy. So gy minus fy dy, this is the answer we people are looking for. And even if you are not very sure about which is the right or left, don't worry, just put the modulus sign. That's it. So this will give you the answer which is actually required by you guys. Okay. Okay, now let us apply the concepts that we have learned directly into the question. The first question says that find the area of the region bounded by the curve y equal to cos x and y equal to sin x when the ordinates are between 0 to 3 pi by 2. So this is from where you have to start, x equal to 0, and somewhere down the line, yes, this must be, yes, this point is 3 by 2, right? So you need to find till now, and the blue is cos function, the red is the sine function, and you can set at 3 pi by 2. We know that sine takes value -1. Okay, so after that, region is not required, so you need to find the area between two curves. So if you see, their first point of intersection is this point, that is pi by 4 is their first point of intersection, and which is the upper curve here? Upper curve is the blue line. So what you will say, first of all, 0 to pi by 4, what you will do cos x minus sin x dx, because the upper curve is nothing but cos x, right? Then let's move forward and we'll go till next point of intersection, the pi by 4 and this point of intersection. Can you tell me what this point would be? This point, yes, it will be 5 pi by 4, that is pi plus pi by 4, right? So we'll go from 5 pi by 4 till 5 pi by 4, which is the upper curve. Now can you see that this is the upper curve, that is the red line is the upper curve here. So what you will do now, you will do sin x minus cos x, you will change the function, and then from 5 pi by 4 till 3 pi by 2, that we have to calculate. If we do this again the blue curve is above the red line, so then again you will say, sir, cos x minus sin x. So this is how you should write this particular question, right? And now you can just quickly solve. I'm leaving that solving part for you guys to solve, right? So every time what you will have to do is that cos x integral is sin x, right? And sin x will become plus cos x, right? You will put the value from pi by 4 to 0 here. Then this will be what? Cos minus cos x, and this will be what? Minus sin x, right? This will be, again you will be putting value of 5 pi by 4 to pi by 4, and then the last is that you will integrate this one. So integrating this one will give you what? Again sin x plus cos x from, you will say, 3 pi by 2 to 5 pi by 4. So just put the value. I hope that you people will be able to solve this. This is a very standard problem that we have taken. Okay, I took this example to highlight that you will need to change the equation or the integrand depending on which is the upper or which is the lower curve, right? Had it been that you have directly written cos x minus sin x from 0 to 3 pi by 2, the answer would have been wrong. Alright. So now in the second question, you people have two curves, that is y square equal to x, right? And the other curve that you people have is x plus y equal to 2 line, right? So now let us again understand the diagram first of all. So y square equal to x. So what is this particular parabola? It is your standard parabola. Remember, y square equal to 4x type. So this is something like this, right? This is the shape of this particular stuff. And x plus y equal to 2. Can you tell me what will be x plus y equal to 2? So x plus y plus 2 would be something of this sort. Okay, so this is the stuff, and you need the bounded region. So the answer that you people are looking for in this particular question is this particular area, right? This is the bounded region. Now the problem here is that how you will integrate, whether you will integrate it with respect to x-axis, right, or whether you want to integrate it with respect to y-axis. This is what I want to teach you in this particular example. So for example, if we go by the first method, that is the x-axis, you need a start point and the end point. So now see that the graph is above x-axis also and below x-axis also, and it is not symmetrical. So what I mean by symmetrical, let me just talk about this also, right? Symmetrical about x-axis. So for example, if I talk about ellipse or a standard circle, so they are symmetrical about x-axis. Symmetrical about x-axis, what do you mean by this function is that the portion which is above x-axis, exactly similar portion is below x-axis. So the area that you need to calculate, so for example, if you want to draw a circle, right, and this is your, let's say, you say this is your x-axis and this is your y-axis. So I say that this area is equal to this area, is equal to this area, and this is equal to this area. So how I will calculate is 4 into area of first quadrant, right? This is what is the usage of symmetry about x-axis and y-axis, right? Area of first quadrant. But I cannot apply that particular concept in this question because this area, the above area, let's say this is the region above one, is different from the area which is below it. So the method of doing it with respect to x-axis actually is very tricky here, right? I can teach you that it could be solvable, but it is very lengthy because first of all, you know the start point here, right? This is the start point, x equal to 0. Then you need to find the intersection point like here, right? Then again from here to here you will integrate upper minus lower. But if you see here, if let's say even if you go by the x-axis method that you find the x equal to a point, right? So this particular region will be upper minus lower, where the upper and the lower are the same curve. Can you see that? You just need to find this area. So this area could be found by using symmetry because it will be nothing but twice of this area, but that will be a very lengthy calculation. The easiest part of doing this is that can we find this YA and YB, right? And if we can find this YA and YB, this question will really become very easy, and that is not a tough job. So if your target is to find Y, so let's put the value of x from here in here, right? So if I do that, this becomes like this, right? Or you can say y square plus y minus 2 equal to 0. This reduces to what? Y plus 2 into y minus 1 equal to 0. This implies y is equal to minus 2 and 1. So this value is nothing but minus 2 and this value is nothing but equal to 1. Now if I say that you can try to draw horizontal rectangles, that is now completely feasible for me, right? Horizontal rectangles are possible now. So if horizontal rectangles are possible, so what you will be required is to solve minus 2 to 1, right minus left, right? This is what you require. So, and now you will integrate with respect to dy, not respect to x. So the right, this is the right curve, right? It is running towards the right. So right is what? X plus y is equal to 2. And now you want to write this as x equal to fy function, right? So it becomes x is equal to 2 minus y. So the first function that we are going to use is 2 minus y here, right? Minus left. So left is the parabola. This is the left part. Left is the parabola here. Parabola is already that if you see it is simplified from y equal to x, y square equal to x. So you will put y square dy. This is what you need to calculate in this area, and you can see that this is a very easy problem now to calculate. Okay, solve this to get the answer of the area as 9 by 2. This is the answer that you people should get. I'm leaving the integration part for you people to solve. All right, now let's check the other question. It says find the area of the region bounded by y equal to root 5 minus x square and y equal to modulus x minus 1. These kind of questions are actually famous in entrance examinations because they are of a moderate level, not of the very basic level, and also ask you some pretty good questions. So how you solve this particular stuff is by squaring, right? So this becomes y minus x square, and if you see this, this is nothing but equation of a circle. So this is nothing but a circle, right? Okay, so this is the circle x square plus y square equal to 5, and it has center as 0 comma 0. So this is what you people will get, that center is 0 comma 0 and radius is root 5. So this point is nothing but root 5 and this is minus root 5. Okay, now the answer to this is that it is not a circle. That is the problem, that we people think that this is a circle. This is not a circle. The error that we commit here is that when you people square from here to here, you did squaring, right? But initially if I do the squaring now, then y can take both positive and negative values, whereas at this particular step this is under root, so under root always returns you positive value, so that means y is never negative. So remember, whenever you square, check for the original value. It is there that y is always greater than or equal to 0, then you can square. Y will never be negative because this quantity can never be negative value. So that means this is not a complete circle. In fact, this is a semicircle which is given to you, right? So we will not take the lower half. It is just the semicircle which is given to you, right? Something like this. This is what is given to you. Let's talk about the second curve. It is y is equal to mod of x minus 1. So people who know that y equal to mod x, you can simply draw this graph by using the concept of y equal to mod x. This is y equal to mod x. So I'll tell you a simple rule. So if x is being replaced by x minus a, what you need to do is shift the graph by a units towards the right, right? And if it is x plus a, shift the graph by a units to the left side. So for example, this was 0 comma 0, that is y equal to mod x. Instead of x, it is x minus 1. So what you people will do, you will shift this graph 1 units. So rather than starting from 0, the graph will start from x equal to 1. So this is the shape of y equal to modulus x minus 1. Okay, now we need to draw this on a complete scale. So let's see what the graph would be. So this is what the entire shape would now look like, that this is root 5, right? And this is point is 1. Now you need to find the area bounded. So what is the bounded figure here that you can see is this particular region? Can I say that this is bounded clearly? Okay, so how do you find the area then? So here if you see that at x equal to 1 ordinate, let me draw it for you, at x equal to 1, right here. So now you need to be very wary of these kind of question. At x equal to 1, the graph is changing its value. So what is y equal to modulus x? It is x for x greater than or equal to 0 and x minus x for x less than 0. So similarly, I can say that y equal to modulus of x minus 1 would be x minus 1 for x greater than equal to 1 and minus x plus 1 for x less than 1, right? So that means this particular line here is x minus 1 line, and this particular line here is nothing but 1 minus x line. Can you understand me? So if you see to the left of 1, this line is something different. To the right of this, some line is something different. So you cannot completely integrate this stuff. Okay, but you need to find their point of intersection. So for example, this intersects here. So the boundary actually starts from here and goes till here, right? So you need to find first of all A and you need to find B, right? So for A and B, what you will do, that's a very simple calculation that you can easily do at home also, that you want to now solve both of them simultaneously, this and let's say if I just solve y equal to x minus 1. Okay, so what that would be? So these are the two answers that you will get. So that means I can say that xb is nothing but 2. That's for sure. This b I have got here, that is 2. And I have got another root that is minus 1. So can you tell me what is minus 1 here? So actually minus 1 is nothing but the abscissa of a also. Why? Because if you extend this, right? If you extend this and if you extend this, this point is nothing but they will coincide. Why? Because 1 minus x and x minus 1 are mirror images of each other. So the I can say the abscissa or the ordinate of this point is nothing but this is ordinate is x equal to minus 1. Abscissa is minus 1 in a way. Okay, and if you're not sure, then you can also do one thing, that you can solve these two simultaneously. Y is equal to 5 minus x square and y is equal to 1 minus x, right? You can solve this and you will again get two answers. The only answer that will signify the answer is x equal to minus 1. So now if you want to solve the area, let's come to the area portion now. We were interested in area. So area is actually divided in two regions. This is the first region, right? And this is your second region now. So R1 plus R2 is the thing which is required. So how do you write R1? R1 is starting from minus 1 to 1, right? Minus 1 to 1. What is the upper curve? Upper is again the circle. Circle we know that is 5 minus x square. Minus what is the lower curve? Lower curve is the line, but which line? Yes, this line when x is less than 1. So we'll put 1 minus x here. What is R2? R2 is from 1 to 2. What is the upper? Upper is again the circle, and bottom and the below line is the when x is greater than 1. This is x minus 1 line. So this is what you need to calculate. And if you want to quickly solve this, you can actually see that minus 1 to 1 and 1 to 2 both have the circle component. So you can directly say that I will integrate circle from minus 1 to 2 minus 1 to 1 1 minus x minus 1 to 2 x minus 1 dx. This is how you need to solve this problem. Now you have to solve a bit of a lengthy calculation of indefinite, and remember that in the area problems, generally in the area questions, that integration that you people follow is generally indefinite integration, right? You will have to follow the indefinite procedure. That is, what do I mean by this is that you'll not be able to apply the properties of definite integration very easily in the area problems. So for example, it is written that here it is 5 minus x square, right? What you will do, you will use the formula of under root a square minus x square to solve this particular quantity. There is no shortcut. So answer to this problem, if you want to check at home, is 5 pi minus 2 by 4. This is the answer that you people should get. Okay, let's take another problem. Just to understand how to draw basic curves, you have to find the area enclosed by the curve y equal to ln x plus e and the coordinate axis, right? So I have taken this problem just to express that how you can draw this particular diagram with the help of this. So you know that this is the curve for y equal to ln x, something like this. So now here if you see, x has been replaced by x plus e, and I just told you that if it is plus e, then you will shift the graph e units leftward. So the actual graph of the diagram that we need is the asymptote that was earlier your 0 line, that is x equal to 0, now will be played by x equal to minus e, right? This is what it will become, and the graph will, let me just draw it again. So the graph will something look like this to you people, right? Something like this. And if you want to find its y-intercept, you can just put x equal to 0. This will be nothing but 0 comma 1 point, right? If you put x equal to 0. Okay, now you need to find the area with the coordinate axis, so you need to find this point as well, that is when y will be 0. So you need that ln x plus e should be equal to 0, right? When will this happen? Can you tell me? So this becomes x plus e is equal to e raised to power 0. You can say it is nothing but at 1 minus e is what this will happen. Okay, so you now know both the points, that the start point and the end point, and you wanted to find the area between the coordinate axis. So this is the area that you need to find, right? So it's very simple question. Now you just need to integrate from 1 minus e to x equal to 0. It is x equal to 1 minus e to x equal to 0. The curve is nothing but ln of x plus e dx. That's it. This is what you were asked to solve. Okay, and if you want, you can actually do the substitutions. If you want to solve this, you can first of all substitute x plus e is equal to t, so dx comes out to be equal to dt. So let's see how the limits then change. It will go from 1 to, yes, it will go, if you put x equal to 1 minus e, 1, and x equal to 0, this will give you e, and this will be what, ln t dt. This is what you need to solve, and I hope that you can very easily solve this particular problem. Okay, the answer to this will definitely come out to be 1. Okay, so just solve this and you will get that answer is 1. Okay, now let's take another interesting problem. It says that you need to find the area of the bounded figure formed by the following curves. So here it looks like that there are only two curves, but they are not two curves because it's the modulus function. So it is y is equal to mod x minus 1, and this particular curve is y is equal to minus mod x plus 1. So actually this reduces to two curves. How it reduces to two curves is that it is y equal to x minus 1 for x greater than equal to 0, and this is y is equal to minus x minus 1 for x less than 0. And similarly we can split the other one also. If you want to split, this becomes y is equal to minus x plus 1 for x greater than equal to 0, and this will be y is equal to x plus 1 for x less than 0. This is what you people can say. Okay, now if you need to draw this particular diagram, let me show it on diagram, what diagram it will come out to be. This is the diagram that you will get. This actually forms a square, if you can see. So let me call L1, L2, L3 and L4, and I'll show you what all lines are these. So L1 line is actually your this line, and you see that this becomes y is equal to x plus 1. How I can tell this is that I'm just calculating x-intercept. So x-intercept is minus 1, y-intercept is 1, which is for line 1. Then quickly tell me what will be the line 2. Line 2 has both x-intercept and y-intercept as what? 1. So what will be the answer here? Yes, this particular line, that is y is equal to minus x plus 1. L3, let's talk about L3 quickly. So L3 has 1 as positive as x-intercept and minus 1 as y-intercept. So this is, yes, this particular line, that is y is equal to x minus 1, and L4 will be the fourth line, that is y is equal to minus x minus 1. So at the first it looks like pair of two parallel lines. So L1 I can say is parallel. So you can clearly see that L1 and L3 are parallel, and L2 L4 are parallel. This is quite evident. This here the slope is 1, and here the slope is minus 1, and that is why I am saying that if the slope is 1 for this one and this is minus 1, so this will be 90 degree, this will be 90 degree, and by symmetry we can say that this, if this is length 1, this is length 1, this is length 1, this is length 1, so hypotenuses are all equal. So the length AB is equal to BC is equal to CD, right? All these lengths are equal. So that means you need to find area of square. So very simple problem now. We know that how to find the area of square, or in fact, let's say this is origin here. So area can be calculated in a much easier way if I say that it is 4 times into area of triangle AOB. Can I say this? So what this quantity will become, 4 into half area of triangle AOB would be what, 1 and 1 base into height, because this is also 90 degree, this is 1 into 1, so the net answer to this problem is 2, and that is the answer. So these kind of questions are very famous in entrance examination. So pay particular attention to the modulus problems. Modulus problems are the ones which are generally asked because they seem to be very tricky, but they reduce the problem to a very great extent. Now let's say questions where inequalities are being involved. So for example, you need to find the area of the intersection of these two curves here. The first curve is mod x less than equal to mod y. Okay, so the trick here is to forget about the inequality part. Let's first of all try and figure out what is mod x equal to mod y curve. Can you tell me what are these curves? So it is actually a combination of two curves, that is x equal to y line and x equal to minus y line. There will not be four curves as in the previous case, which is very obvious, because if you put both minus here, it will again lead to minus x is equal to minus y is nothing but equal to x equal to y. Okay, so the shape of this curve would be so y equal to x line, right? So let me draw this is y equal to x line, and this could be y equal to minus x line. Let me just draw it. Right, something of this sort. Don't mind the diagram because it's exact. It is a straight line. So this is actually y equal to minus x line, and this is equal to y equal to x line. Okay, so now we will get into the inequality part. So you were asked to find mod x less than mod y. So can you tell me in how many portions the graph is being divided? So let's say this is the first region. Can you see this is the first region? So I'll say region 1. This is region 2. This is region 3, and this is region 4. So you need to find out which particular region is your favored region. And for that, that is very simple. That you can do is just take a point in each and every region. So let's say I'll take a point 1 comma 0 for region 1. Is 1 comma 0 satisfying this? Just put it. It is 1 0. 1 is not less than 0. That means region 1 is not the required answer. For here, let's take 0 comma 1. Is 0 comma 1 satisfying? And yes, 0 comma 1 now satisfies because 1 is greater than 0. So that means you require this region. This is your favored region. Similarly, let's put minus 1 comma 0 for the third region. Let's say this was for R2. I check R3 by this. So R3 again will be 1 less than 0, which is not the favored region. For R4 also we can follow the same trick. I'll put 0 comma minus 1, which again yes satisfies. So this is also my favored region. So that means for this particular curve we'll take region 2 and region 4 as our favored regions. Got it? And the other one is nothing but a very simple stuff, that is x square plus y square less than equal to 1. So for again this, what you will do, x square plus y square equal to 1, we know that this is a equation of circle, nothing else, right, with center 0 comma 0 and radius 1, and it is less than equal to 1. So take any point 0 comma 0, it lies inside the circle and it satisfies the condition. So that means it is inside the circle. So this is what is how you solve inequalities. So if I take the net diagram, so this is the net diagram where this is the circle and this is mod y. Now we wanted the common region between them. So what will be the common region? Region 2 and region 4 and the region which lies inside the circle. So inside the circle would be something like this, right? and this particular region. So you want this particular shaded region as your region, right? Okay, so this is the favored region that you want. And now can you see that it is a completely symmetrical figure? It is completely symmetrical figure. What do you mean by symmetrical figure? Again, I repeat that it is as much above x-axis as much it is below. It is as much towards its right as it is towards its left. So symmetrical about both x and y axis completely. So for example, if was your region 2 and this was your region 4, right? So the area that we require to find is nothing but 2 times into region 2. That is what we need to find, right? This is how you generally solve ellipse, circles, all symmetrical figures. Okay, so the answer then would be nothing but 2 into. Now how do you find this? For this, obviously you need to find 2 points first of all, this A and this B, right? So how you will find this then? Okay, and in fact if you see, if you want to find from A to B, you will have to split this into two parts, one portion and the other portion. But again, if you go by symmetry, this sub-region of R2 will be equal to sub-region of R2. So I can say this region is also divided into 2 into sub-region 2, right? Let's call this. So I am calling this particular portion, right? This is SR2, that is sub region 2. So the answer then becomes this into sub region 2, or we can say 4 times sub region 2. So this is the beauty of symmetry, if you can understand. So this will be equal to this, will be equal to this will be equal to this, very, very easily. So now the only target is to find the point B. Point B is nothing but intersection of this line is y equal to x with the circle. So you need to find intersection of x plus y square equal to 1 and y equal to x line. So can you tell me what will be the answer? Very simple answer, yes. 2 square is equal to x, and we need only in the first quadrant. So first quadrant point will be 1 by root 2. You will get another point which is minus 1 by root 2, which will be in the third quadrant. So the answer to this problem then, area would be nothing but what area could be written. So sorry, my original diagram and the original question has gone. So just continue it from there, that we were trying to find 4 into area of sub-region 2, right? So this is nothing but, we already got that this point is nothing but what, 1 by root 2 comma something, and which I am not interested in the ordinate. So the answer is nothing but 0 to 1 by root 2. What is the upper curve here? Upper curve is the circle. So you will say circle, and the lower curve is line. Circle minus line is the answer, and you are integrating with respect to x here. So this reduces to nothing but 0 to 1 by root 2. What is the equation of circle? Circle is x square plus y square equal to 1. You need to write it as a function of x. So this is what you will write. So this is 1 minus x square, minus line is y equal to x. So this is x dx, right? So this is what you would be required to solve for this particular answer. Okay, so again, as usual, I'm leaving the part of integration for you guys. Remember this, again you will solve something like this, a square minus x square component, which is the lengthy formula where x by 2 under root set 3 formula basically, right? I am just giving you the hint how to solve this. This is the set 3 formula of integration that you people will have to use. The answer that you should obtain, I am giving it to you, is pi by 2. Okay, so solve and get this particular answer, and I hope this concept is clear, that what is modulus and inequalities are used in areas. Okay, now let's take other problem which I believe is in your NCERT as well, and I'm taking this because it's something that I want to teach you here as well. So there are 3 curves here rather than 2 generally, which are given in the question. So this is the first one. The other one is 0 less than y less than x plus 1. So I have seen that people generally mess up with when these kind of things are given, right? And believe me, this is very phenomenal, very easy. For example, if I talk about this is nothing but from x equal to 0 and x equal to 2. So all the region that you people have to draw is between these two lines. Okay, this is nothing but, for leave the inequality part, just understand why this is a basic graph. Okay, sorry, this is plus 1 also here. So it is x square plus 1, that's it. Similarly for this, it is nothing but y equal to x plus 1 graph. Okay, and here it is given that y will be positive, right? Y is positive, this is given, or equal to 0, and also here it is given that y is whatever value you take. So when y is greater than 0 is given, that what do you understand by this? That means you have to take graph which is above x-axis. So you will only accept those values or those portion of graph which are above x-axis. You will not take the graph which is below x-axis, because for that y is less than 0. Plain, very simple. Now, how do you draw a graph for y equal to x square plus 1? I told you that if the changes in x is in terms of plus or minus, for example here, that you want to draw y equal to x plus 1. So for this you can draw y equal to x line and x plus 1. So shift plus 1 for shift leftward the graph by 1 unit. So this is the graph of y equal to x plus 1. But here the change is not in terms of x, it is in terms of x square. So rather take this change in terms of y. You have to just count. So whenever I'm taking this, this is basically called transformation method, which we teach in advanced level in topic function. This is called linear transformation, right? What we are doing, linear transformations. Okay, so but remember that linear transformation have to be done. So if y minus 1 is done, that means you will draw y equal to x square and shift the graph 1 units above. Had it been that it was, let's say for example, y plus 1 equal to x square, so you would have done what? You would have drawn y equal to x square and then you will have shifted the graph 1 units below, right? So if you say that sir, the graph of y equal to x square is something like this, so what will be y minus 1? Y minus 1 will do nothing but shift the graph 1 units above the x-axis. That's it. So this is the graph. So now you have both the graphs available. That is, this graph is there and this graph is there and this condition is there. Let's see what will be the net outcome of the all these things. So this is what the diagram would something look like. This is your parabola here. That is the red line is nothing but y equal to x square plus 1, and this blue line is nothing but y is equal to x plus 1 line. Now sometimes I have seen that students generally start solving very quickly and they start finding this particular small region. Can you see this particular small region? They start calculating this. Wait, we need to find out what actually is required from us. Let's see. So now we were to solve y greater than 0. So coming back to your original problem, y greater than or equal to 0 less than x square plus 1. So that means y has to be positive. This curve is already above x-axis, so not a problem. So you want y less than equal to x square plus 1. As I told you, now you have parabola. So parabola has this particular region which lies inside and the outside of the parabola. Check by putting this particular point, that is 0, 0. So is 0, 0 satisfying this criteria? Let's put 0, 0 here. And yes, 0, 0 satisfies the criteria. So that means we need that portion which lies below the, so you need the area which lies below this particular belt, complete here, right? Complete, something like this. Okay, now let's talk about the other curve. The other curve that we people were having is this particular one, right? So how do you are going to solve this now is y is greater than 0. So that means you will say you don't want this particular region, you want the region above x-axis. So you were having something like this, right? So this particular quantity says above x-axis, right? Now the left portion is again this region. Again use 0, 0. So is 0, 0 satisfying? Yes, 0, 0 is again satisfying. So that means you need that portion where 0, 0 lies. So now if you see that again is this particular region, right? This region. But you wanted it the region which is outside the parabola also. So in fact it contradicts the fact you do not want this particular region, you want the region which is outside the parabola. Remember, and you wanted it to be integrated from where? Now the third context, you want it from 0 to, yes, so the net region that you want now is, it will start from here, somewhere here, then it will go for x to 2. This is what you people are looking for if I have to highlight completely for you guys. So this is the area that is actually the requirement, right, till here. Remember, you do not require inside parabola, you need it outside the parabola. So this is the blue portion that I have shaded is the region which is required. Now, how do you find this region? Can you tell me? That's again a problem in itself. So for this, you need this particular point A. How do you get this point A? This is very simple. You need intersection of x plus 1 and y is equal to x square plus 1. If I do solve this, this comes out to be y equal to x square plus 1 plus 1, right? Clear? So this can be easily said that they intersect at 2 points, that is x equal to 0 and 1. So 0 is this particular point. So A comes out to be something 1 comma, you can say 1 comma, if you put 1, 1 comma 2. So A region is 1 comma 2. So how you will integrate this is, so area then will be splitted up in two regions again. Why we need to split this in two regions? This is the x equal to 2 line, right? Let me draw it. Sorry, x equal to 1 line. So this is one region, right? This is one region which is actually lying below your this particular parabola, right? And this the other region over here, this particular region, right, is this region is nothing but it is lying under the line region, plane line, right? So if I take this as my concept, so the answer is nothing but 0 to 1. What you will integrate? Parabola. Parabola is very simple, that is x square plus 1 dx, and from 1 to 2 you will just integrate the line. That's it. That is x plus 1. That's it. That's the question. Okay, again as usual I'm leaving the part of solving to you guys. So if you want to check the answer should come out to be 23 by 6. Right, this is the answer that we should get. Let's take another question. It says find the area of the region bounded by the parabola. So now parabola is not in the standard form, though it's in the standard form, but not the regular one, that is y square equal to 4x. So if it is y minus 2 square is equal to x minus 1, so we know that the vertex of this parabola is nothing but 1 comma 2, that is this particular point over here, right? So people who do not know how to solve this, just please go and watch the parabola video, right? Just watch the parabola video because this is completely basic, and if you will not be able to solve the area topic without knowing all these facts. Okay, and now the tangent to the parabola at 2 comma 3. So let's say this point P over here. So this P point is 2 comma 3 where you have drawn the tangent and the x-axis. So what first of all region that you are expected to find? So this is the x-axis. So this is the particular region that you guys are expected to find, right? And again, as if you can see that if we start drawing the vertical lines, it becomes very difficult to find the question, right? So if I draw a vertical line, that is completely challenging. Whereas if I take something of the left minus right, this is completely very simple. Why? If I do something from A to B, right minus left, right? So right minus left, I have only single curve, that is this particular parabola. So right is nothing but I am knowing that it is parabola, and which is very simple again, because if you say parabola, this becomes x is equal to y minus 2 whole square plus 1. So it is of the form y equal x equal to fy, which is not even in the under root. In fact, it's into very simple form. Left is nothing but a straight line, right? This is straight line which we need to find out which is the tangent actually, right? And you need to integrate it from, this is the value of minimum value of y from here x-axis, that is y equal to 0. And if you see properly, you are already given the ordinate. You were to find till this point, right? What is the ordinate of this? This is 3. So that means you just need to integrate from 0 to 3. Can you see that how simple this question now becomes? Now our target is just need to find the equation of tangent at P. This is the target. So nothing, just find dy by dx. We know how to find tangent, right? So what is the dy by dx? 2 times y minus 2 dy by dx is equal to 1, or I can say that dy by dx is nothing but 1 by 2 times y minus 2. This is what value you will get. And if you put the value of 3 here, so dy by dx, or let me write here, so what will be the value of dy by dx? Yes, so dy by dx at P comes out to be what? Simply 1 by 2. So what will be the equation then? Y minus 3 equal to 1 by 2 times x minus 2. This is what you will get, which is nothing but 2y minus 6 is equal to x minus 2, or 2y minus x, right, minus 4 equal to 0. And since we need x equal to fy form, we can say x, yes. So now we have got our answer. We know the parabola, we know the straight line. So the area is nothing but equal to 0 to 3. What is the parabola that we have to use? Yes, now remember that we use fy function because we are integrating with respect to y, right? And the line is nothing but 2y minus 4 dy. This is what you will solve for this particular question. Okay, and again as usual, you guys are going to solve this. The answer that you should get is 9. All right, I hope the concept is clear though in this particular question. So by this we come to the end of this particular chapter. I know that the questions that I have taken in this particular video were very easy. The reason is very simple because it is asked at that particular level. So in fact, if you want to practice area, it's better that you solve it with respect to your board level problems, because that kind of questions are going to be asked at JEE Mains level. Though honestly speaking, JEE Advanced is completely different because it is based too much on the graph and how to make graphs of difficult functions. But yes, till mains level there is no problem, and I'm not focusing more than that. I do not want you to get demotivated by taking a very tough problem at this point of time where board is very much near. All right, so I request first of all you guys to go through functions topic where we have done the basic graphs, then go through the basic conic sections, that how to draw the basic shapes when they are not in the standard form. Up till this level, the JEE Mains people can ask questions, and this is what I want you guys to go through first of all. Okay, I'll be sending the worksheets. Just try to go through it, solve it. I hope that most of the problems you will be able to solve. So don't worry about them. And for the NCRT problem, just go and watch the channel for the respective problem. Okay, so I see you with the next topic tomorrow. That is differential equation, which is something really important. So good night from my side. Till then, good night.